to start it. Thank you. Okay, so first thing first, I need to balance this reaction. So I know I have magnesium, and I'm going to make magnesium fluoride. This will be MgF2. I have magnesium plus F2. Well, that's super convenient. How come?
Because you don't need a balance.
All right, it's already balanced with just ones. So in this problem, you could screw up and still get the right answer. Now, can someone tell me why this 2 is there? Yes, it's diatomic. Can someone else tell me why this 2 is there? Because I need 2 fluorides to offset that. They're not there for the same reason. They're there for extremely different reasons. So make sure you understand chemistry. This would also be an oxidation reduction reaction, in case you wonder. How would we know that? Can the third person tell me how I would know this is an oxidation reduction reaction? Because there are single elements. All right, tell your partner which one of these 2 would be oxidized, and your partner tell you which one would be reduced. Okay, I got a question. If fluorine is the best looking, nicest, most popular, richest person on the periodic table, can anyone steal his girl? No. Fluorine will never lose electrons. It will always be reduced. Magnesium was oxidized. Okay, that's not really part of this problem, just kind of a review. Okay, I need to find the molar masses of the species. So I need magnesium, right? Good, that is 24 grams. Oh, that's ugly. Let me write it down here. Magnesium is 24 grams per 1 mole. And then I need magnesium fluoride. So that's 24 plus 38, so 62. Okay, then I set up the picket fence with the thing I was given. I was given 65 grams of Mg. Tell your partner what unit goes down there. Grams of Mg. I can find that right here. For every 24 of them, there is 1 mole. I don't like this red on blue background. Is that bugging anyone else, or is it just me? There we go. All right, now, this is Mg. What comes down here then? All right, I'm going to put mole of Mg. Someone said 1, and that's correct, but let's talk about why it's 1. Where does this 1 come from? All right, up here. A question real fast, just real fast. Tell your partner, is this 1 and this 1 related in any way? No, it's not. Okay. This 1 comes from the balanced equation. This 1 comes because when we find the mass of something, it's always per 1 mole. Okay, they're the same value, but they're there for different reasons. Okay, then let's start our way from the end. What do I want to solve for? All right, and the unit at the end is always the unit at the end. And I have a proportion for that, right? It's right here. 62 grams of that per 1 mole of that. Then what unit must go up here? I don't know why I switched, but whatever. 1 mole MgF2. Then I'm ready to do math. 65 times 62 divided by 24. 167? Okay. Winner. It would technically it'd be 170. What do you mean? Yep. When I get to this box, it's like, I don't know if you have driver's ed and they said never guess. A picket fence, there will always be something that tells you what goes next. But when we got to here, there wasn't something obvious that told me what goes here. Now, you guys, you're smarter than average, so you might already know. Well, that's the moles of the thing you're solving for. But you don't have to guess. You go backwards, and it will force you to put what goes here. So start at the first, start at the end, and then meet in the middle. And the middle will always be the ratio of coefficients, which is this blue box. Okay. Let's look at one that is printed. Okay. This problem, if you have notifications on, you saw I uploaded an assignment on Canvas. It is 6 practice stoichiometry problems. This is one of them. So this one's tricky. I'm going to start a timer for 6 minutes. I'm going to do the chemistry for you because half of you are going to take 6 minutes to write out the equation. Barium chloride is BaCl2. Sodium sulfate is Na2SO4. A double replacement reaction, that's what we've been calling a metathesis or a precipitate or whatever, so we end up with just switching partners. BaSO4 plus NaCl. Okay, I'll take you that far. You balance it, because I promise it's not balanced, and you do the picket fence. Now, I'm going to pause this recording. If I don't unpause it, you are all getting a U. All right, so you got 10 seconds remaining. We can get rid of this. All right, so let's just work through this together. Will you first actually check with your lab partner and see what they got? Bennett, is my math wrong? Okay. Okay. Well, OCD kids are going to love this picket fence. Okay, are we ready? Uh-oh. So, all together, my beautiful friends, what am I going to put in the top left-hand corner? All right, 3.5 grams of sodium sulfate. Okay, I am going to do something that I encourage you to do if it makes sense. If it doesn't make sense, don't you dare do what I'm about to do. Yes, ma'am.
Would it even be necessary balancing the equation?
We should balance it, but those two ended up to be ones.
Yeah.
Okay. And then everything else is a 1.
Yeah.
Okay, so the question was, is it required to balance? I guess no, but yes. It would have just been luck if you forgot to that they were both 1s. Okay, please look real quick. Don't do this if it doesn't make sense. But I'm going to take these formulas from now on and I'm going to call them A, B, C, and D so that I don't have to write the same crap over and over. So just follow me. A means BaCl2. B means Na2SO4. So are we ready? This is just to make it quicker. So I have 3.5 grams of A. Why would I do that? Well, sorry, it was B. It was B. Sorry. Because I don't want to write Na2SO4 right here, right here, right here, and right here. Okay. So I'm going to bring down grams of B, and that's tied to, all right, 1 mole of B, which is really 142 grams. So far, we okay? So what must come down here? Mole of B, and what's in front of B? A 1. Okay, now I don't know, there's nothing that tells me obviously what goes here, so then I start at the end. What am I solving for? Grams of A. Are we okay with that? Meaning grams of BaCl2. So the unit at the end is always the unit at the end. That's grams of A, which is 208, because A represents BaCl2. Whenever I find the mass on the periodic table, it's per 1 mole of the same thing. So what unit must come up here? Mole of A, and that happens to be a 1 again. They are not always 1s. 2 examples in a row that were. We can still be friends, I believe. So now, math-wise, I take 3.5, times it by 208, and divide the answer by 142. And I get 5.1 grams of A. Now, if you do this trick, don't write this on the periodic table or on your AP test. I mean, put 5.1 grams of, what was I asking for? BaCl2. You would probably, it depends on the mood, but you would probably get that right. But this is technically the answer. So if you don't like the A, B, C, D thing, that's fine. It's just to save you a little bit of time. Okay. How do we feel about that? Who had it right? All right, good. What did you need, team? You what? Oh, I know you love them. Okay. Okay, we won't do this whole piece, but once in a while, this is from the old textbook, and once in a while you're not asked for grams, you're just asked for moles. So it's actually less work even though it gives you a heart attack. It says how many moles of HF are needed to react with 0.3 mole of Na2SiO3. Now, we don't need this big of one, but I'm not going to bother erasing it. So it's the process. What do I start with always? The number and unit of the given, which was 0.3 mole of what? Can I just call that A because I feel like it? That's a big thing. Moles of A. What unit? Yeah, me too. What unit goes down here? Mole of A. What's the number in front of A? 1. This was already balanced. You'll see that there's numbers here. So if it was blank, it was a 1. Okay, now, what is it asking me to solve for? All right, mole of HF. That is all that I have left to do. I have 8 mole HF per every 1 mole of sodium silicate right here. So mole of A disappears, and what am I left with? Mole of HF, and that's all I need. Do I need grams? Nope. Did it give me grams? Nope. So this piece right here, I've been using a term for it. All right. Oh, that is, I thought it was good. Well, fine. This is the ratio of coefficients. We've been using it all along. It was right here. It was right here. It was right there. But that one, these were all jammed between grams. But I didn't need to. I needed to go, look real quick, from moles of something to moles of the other thing. It was just a super short picket fence. Now, those are pretty rare, but just showing you that it's just a process. Start with what you're given, find what you want, and set up the picket fence. Yeah, this is, I mean, it's out of the AP textbook that we used to use, but yeah, it's a pretty typical one. Okay, yes?
So most of the time they give us a balance equation or really not?
If you're going to do stoichiometry, usually they'll have it already balanced for you.
Is it just to give you?
But that's only usually. What's that?
Is that just to make it so you have less storage?
Right, well, yeah, they'll test you whether you can balance in other places.
Yeah.
So they want to know if you can do the math. They don't make you do both most of the time. Okay, now, limiting reactants, like any good infomercial, but wait, there is more. And this is where, I don't know, it doesn't get harder, it just takes more time. Our 4 inches of paper to do a problem goes into 8 to 10 inches of paper. So here we go. We have been making an assumption the entire time. We have been assuming that we had enough of the other reagent to react with the given. But what if we don't? So just look, if I say A plus B goes to AB, and I want to know how much AB you can make with 50 grams of A, I was always assuming that B never ran out. We can't assume that. Because the amount of AB produced is dependent on both how much A and how much B I have to start with.
So you don't have to reduce.
So we don't reduce, we have to do some more equations. Whoa. It'll make sense, I promise. We have a little activity. Okay, have you ever wanted cookies on a Sunday and didn't have eggs? Well, then you've experienced the consequences of limiting reactants. If you don't have an ingredient, do you cook the food?
No.
Except when you pour the cereal and then realize after that you're out of milk.
Well,
Then you have a bowl of cereal. Just
well, whatever. If you've ran out of gas, you've experienced the consequences of a limiting reactant. It's not the oxygen in the atmosphere that ran out. It's the octane inside your vehicle that ran out. Okay, see this can right here on my desk? Right here. You're all going to do this same activity. Why not? It's a piece of cake and it helps you to think it through. So right here, I'm going to dump out a ton of chips. Come over here and grab 2 of the same color, or 10 of the same, whatever it says. 10 of one colored chip and 12 of the other. Here, I'm dumping these out too.
So 12 of one
I
color?
don't know how to count.
10 and 12. 10 and 12. It doesn't matter if you're perfect. Oh boy. Excuse me, sir. You're good. Let me dump some more of these bags out over here. All right, you guys in the back, come over this way. I'll pour some right here. Someone open that one for me. 10 of one color, 12 of the other. Okay.
That's how you just slide them all into your hand. That's what I'm trying to do.
This gives me
She's doing what she's supposed to be doing. Okay, now, what you're going to do is make as many Al2O3 molecules as possible. So I'll show you what I mean. So Al2, I need 2 reds, or whatever color you chose, and then I need 3 blues. This is the formula of Al2O3. You need me to grab something? Did you get it? Okay, make those if you would. You're making as many of these as possible. Oh no.
Like I'm gonna convert this to the next one. Put this in the savings account. I have a solution.
That's Christmas colors.
I solved it.
What'd you do?
The sack goes.
You cheated?
Cheating in chemistry.
Al2, Okay,
A little fusion here and there.
so please discuss this with your partner. How many completed models could you make? What prevented you from making more? What did you have any leftovers? Ready, set, go.
Every training circle I will give you what I need.
Okay, here we go. That's not very straight, but I don't care. All right, we need to learn some vocabulary based on this. This reaction is an example of a limiting reactant problem. The limiting reactant, which is typically just written as the LR, is the reactant that should be a T or a, oh, it's ugly, runs out first. Oh my gosh, Tom Davidson. Okay, so from this picture, what reactant ran out first? All right, we ran out of oxygen. Okay, because look, there was still plenty of aluminum to go, but I didn't have the 3 oxygens. The oxygen was the limiting reactant. So what would you guess we would call the other thing? No. No. Excess reactant. The excess reactant is left over.
What happens to excess?
It just chills. Hold on.
Start the new one.
All right. So the excess reactant doesn't really do anything. It floats around in the air, or it's in your beaker, or it's just in the pile of all the stuff, but it's hanging out. It had nothing to pair up with. So it's like musical chairs. These are the two losers at the end that didn't find one. Okay. Now, when we do limiting reactant problems, we will take our reactants and we will calculate how much product we can make, and we'll calculate how much of the excess there is left over. Now, we need to absolutely understand the following. Let me see if it's on a slide coming up. Nope. All right. The amount, oh, this is behind, which is just making it even worse. Oh my. Well, I'm writing too fast. The amount of product produced is determined by the limiting reactant. We cannot make more product than the limiting reactant gave me. So if I would have just asked you in this activity, based on the amount of aluminum, how many Al2O3s could you think you would make? You would say 5. Because you had 10, it took 2 each, so you should have been able to produce 5. We all right with that? But we know that we didn't, because we needed how many O for each one? 3. We had 12. We had 3. We could only make 4. Okay? This would tell me that that was my limiting reactant. The limiting reactant, when we do basic math like this, will be the one that always produces the smaller matter or amount. Now, I shouldn't say it's basic math, because it's not. Okay. Are we sort of okay on what we mean by limiting? All right. It determines how much is made, and we need to be able to calculate how much will be made. We need to identify what thing is the limiting reactant, and then determine how much excess is left over. Okay? So here we go. This is a limiting reactant problem, and it will take us the rest of the hour probably. What? Yeah, we'll be all right. Here we go. Solutions of lithium carbonate and silver acetate react to form solid silver carbonate and a solution of lithium acetate. This has been the test question for years. A solution contains 6.25 grams of lithium carbonate. Sorry, containing. Don't ask, Cooper, I already said it. A solution containing of 6.25, I keep screwing up. A solution containing 6.25 grams of lithium carbonate is mixed with one containing 3 grams of silver acetate. How many grams of each remain at the end of the reaction? So I want to know the grams of this, the grams of this, the grams of this stuff, and the grams of this stuff. Now here's the good news. One of those answers is 0. At the end of this reaction, one of those 4 things, its mass is 0. Which one do you think that would be using our new vocabulary words? Perfect. The limiting reactant. So one of these 2, the ending mass is 0. Okay? The mass of the other one of these 2 would not be the limiting reactant. It would be called the excess reactant. Uh-oh. Okay. What's wrong? We good? Okay, so let's follow this logic. First, balance. 1, 2, 1, 2. That was already done. Second, find the molar mass of each component in the reaction. So that's all of them now. Okay, we already balanced. So here we go. I did it to save time. I'm sorry. Yeah, these do take a long time. If you're doing homework problems, use your phones. If you know the names, that might be hard, but let's see. Hey Siri, what's the mass of lithium carbonate?
The answer I found is 74.017 atomic
Okay,
mass
so
units.
like use an electronic device if you're doing it to save time. All right, these numbers are found using the exact numbers that are on the periodic table I gave you. Okay, so that's Siri must have rounded. Okay, so we've balanced and we've found the molar mass of each component in the reaction. Okay, the next step is to determine the limiting reactant. Are we ready? Okay. To solve for the limiting reactant, you make 2 picket fences that start with each of the given masses of reactants that solve for the same product. The one that produces the least is the reactant that is limiting. Read that a few times. We make 2 picket fences that start with the 2 different reactants, but we solve for the same product. Right. Well, no, you use the givens to start with. We'll do it together in a second. But it's essentially like this. You're at home and you're like, I don't know how many cookies I can make. I'm going to take the flour and do some math to see how many cookies, and the chocolate chips I have and do math. And whichever one produces the less cookies, that's the one that will determine how many total cookies you could make. All right. So are we ready for that, or did that just give you all anxiety?
Yeah, so like on this one, you would start with 73 and 166. That would be the given masses.
No, the given mass is here. Now you'll use these in the picket fence. Uh-oh.
What is that noise?
Now, these are kind of rewarding when you get done and you're right. They're kind of super awful when you get done and you're wrong. But you won't. You guys are geniuses. All right, my feedback should not happen now. Okay. Let's just do it on this slide. We might as well. If I go to that other slide, you'll freak out again. So I'm going to just do 2 picket fences. Now, if you're just hanging on the edge, please pay attention to every single thing I do. I start with the 2 givens. One was, okay, to save me time, I'm also going to definitely use my ABCD system. Are you okay with that?
Yeah.
A, B, C, and D. Okay, so I have 6.25 grams of lithium carbonate. So that's A. My other one, I start with 3 grams of silver acetate. That's B. Okay, now please keep looking at the screen if you need my help. I solve the right side for the same one of these. So I'm going to solve for grams of C. So the start is different, but the end, it has to be the same one. Okay, now I'll set my picket fence up. I won't put numbers in yet. I know I have grams of A, and that would be per 1 mole of A. That means I have mole A here, and then I go to the end. The grams of C have to match here to here, and that would be 1 mole of C. And up here would be mole of C. All right, so yeah, let's fill in numbers. Grams of A was 73.89. Mole of A is a 1. Mole of C is a 2. Grams of C is 60. I'm just going to round that to 66 because I'm lazy and I don't have enough space right there. Okay, that one's completed. Now I'm going to come to the bottom and do the same thing, but I'm doing it for B to C now. I have grams of B, 1 mole of B. Down here, I have mole B. The end is the same here since it's both C. 66 grams of C, 1 mole of C, mole of C. Now I look up here, there's a 2 in front of C, and there's a 2 in front of B. The mass of B comes from here. I'm going to just round that to 167. Okay, now I do math. I solve both of these. Thank you so much. She left the school. Yes.
So why are we finding C again? Sorry, I just got
It's fine. We could solve for C or D here. It doesn't matter which one I choose. But what I'm finding out is, does this produce more C or does this produce more C? The one that's the smaller answer is the one that will govern how much C is actually made. Nope. Right. It could be either one of these two. And you know what I always do? I usually choose the one with the smaller number of grams. And there's no reason to, but that's just Tom Davidson right there. Okay. Does anyone have a number right here for me yet? The top one is 11 point what? 17. Will someone verify that? It's not that I don't trust him. I don't trust anyone. Okay. It's all right. I have a saying in chemistry, and it's that in the calculator of 2 or 3 nerds shall every number be established. So if we can get 2 people get the same math answer, we're usually right. Yes, sir. I could choose C or D. On the end? I don't want to solve for it yet. I will. But to determine which one of these runs out first, I need to do 2 for the same one before I do the other one. 11.7. Sorry, 11.17. Okay, bottom one. Do you have that yet, Fabian?
That one is 2.37.
Do we agree? Uh-oh.
Wait a minute. Oh, I forgot the 2 on the bottom. That was my bad.
So 1 point something. What'd you get?
I got 1.18. So really, it'd be like
1.19?
1.1.
Okay. Go ahead, Cooper Lloyd.
So, with the picket fences, isn't it just the unit of measurement is the only thing that, so like, see how there's 2 mole C on the top one? But you wouldn't carry the 2, right? It's really just carrying the unit.
I only move units. I never move numbers. Okay, now, please watch what I'm about to do. It bugs a lot of people, but I don't care. Which one of these is the smaller number? This one, right? So please do the following. Why am I getting rid of that?
We don't need it anymore.
Because that wouldn't have happened. That number assumed we had plenty of the other one, but do we? No, this is the smaller value. That means this is the maximum amount. Get rid of this, especially this answer, because you're never going to use it.
So the smaller answer is the answer.
Yes. Now, we're not done yet, but let's look at what we have. We know, please stick with me, and we'll do a bunch of these. But we know some things now that is the final answer. We want to know how many grams of everything. We are now halfway done. We know we have a 1.19 grams of C at the end. That is an answer.
And now we need to do it again for D.
We will do it again for D, but we also know another thing so far. Look at right here. Now be very, very careful. I need you all with me right here. A ton of people, they get this and they're like, oh, C is the limiting reactant. But it's not. You need to look right here. That is your limiting reactant. So Nisha, you figured this out a second ago. What's the mass of B at the end then? Okay, maybe it was Bennett, but the limiting reactants grams at the end are 0. We have 0 grams at the end of AgC2H3O2 because it was completely consumed to make A or C and D. Okay, now I know you're like, what? Here we go. We've done that. Next, use the limiting reactant to solve for grams used. Whoops, we're here. Sorry. We are up here.
So we basically do the exact same thing as the bottom one.
Yep, but now we solve for D. So here we go. We're going to solve for D starting with the same start my limiting reactant had. So it's pretty easy. I have 3 grams of B, 167 grams of B, 1 mole B, 2 mole B. But now what am I solving for? I'm solving for grams of D. So this will be grams of D, 1 mole D. Then I come up here. D in front of it has a 1. So I have a 1. I should have stayed up there. The mass of D was 275.75. And then I'm ready to roll. I multiply all the top, then divide by the bottom. What's that? 2.47. Do I get a second? Okay. Now, we are 3/4 of the way done. This was what? 2.47? That's how much of D we have left. So what's the only thing left to do? To solve for the amount of excess reactant left over. There are 2 ways to do this. One is when you're in a hurry, but it's not a good idea. But we're in a hurry. We are going to add these 2 and find the number. Someone add that for me right now.
Is it not a good idea because it doesn't check your answer?
Right. 3.6 what? 6. How much mass did I start with? 9.25 minus this will tell me the amount of excess. That's the fast but not smart way. What's this number right here? What? Now, I will teach you the better way tomorrow, because this right here, this is right as long as we didn't screw up.
Wait, can you scroll down really quick?
Yep. The problem is you screw up a lot. If you find the excess and then the 3 of them don't add up, then you know it's time to drop the class. Okay, that was a little over dramatic. Yeah, put those chips back if you